Hi guys, today we are going to continue dividing polynomials, but this time around we're not going to do long division. We are going to use synthetic division. Synthetic division is what is that? Synthetic division is a shorthand for long division, but it's a shorthand for long division when we are dividing by a binomial of the form x minus r. So the book uses x minus r, but for like everyone in general, synthetic division is a shorthand when we are dividing by a binomial of the form x minus a number, okay, whatever that number may be. The question is, what if we are not dividing by x minus a number? Then we cannot use this technique, okay, as simple as that. Cool. So I'm gonna try to break down this technique with this partially set up problem. Okay. So we are asked to divide. You know, we have a degree 4 polynomial, and we're asked to divide by x minus 5. The directions don't specify what technique to use. The directions don't specify if you have to use long division or synthetic division. But for me, I'm always gonna ask myself, can I take a shortcut? Synthetic division is not a shortcut, it's just how I speak, okay? It's a shorthand for long division. So I'm like, okay, can I take a shortcut? Can I divide by using synthetic division? So I'm like, I don't know. Am I dividing by a binomial of the form x minus a number? So again, our book uses r, and in this case, yeah, we are dividing by a binomial of the form x minus a number. So in this case, the value of r is the number that follows the subtraction sign. The number that follows the subtraction sign is 5. So in this case, r will equals 5. Okay, so now we're gonna go ahead set up our division box. I know that's not a box, but I don't know how else to say it. Okay, we're gonna go ahead set up our division box, which is just an upside down into symbol. Like the long division, the into symbol is like that, and if you flip it over, that's upside down. So that's how I speak. How's it gonna go down? So outside the division box, we're gonna put the value of r. Okay, the value of r, as we said, is 5. And then inside the division box, we should have enough space to fit 2 rows of numbers. So top row and bottom row. I'm not gonna highlight again in the next problem. It's just I wanted to let you know where these numbers go. So in the top row, we're gonna put the coefficients of the dividend. That's code for what are you dividing into. So a lot of books don't do this, but I do this for myself. So I like to highlight the degree. The degree is 4, and we're gonna go ahead write down the degrees above the top row. So the first coefficient should be the coefficient of the x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, constant, okay, which is our degree 0 term. So 4, 3, 2, 1, blast off. The reason why I like to highlight the degrees is because I feel like it helps me to set this up a little bit faster, especially if the terms are not in descending order, and it also helps to highlight if we have a term for the missing power of the variable. So again, for synthetic division, just like a long division, we need to make sure that the dividend is in descending order, and then we have a term for each power going down. If we have a term missing, then we put a 0 placeholder. So let's go ahead complete the top row. So in the top row, we're going to put the coefficients of the dividend. So for the degree 4 term, the coefficient is 4. Got it. The degree 3 term, coefficient is negative 22. Perfect. Degree 2 term, coefficient is 9. Awesome. Degree 1 term, just kidding. Okay. We don't have an x to the 1st, so we're going to put a 0 placeholder. Okay, cool. So we have a 4, 3, 2, 1, and our degree 0 term is the constant term, and apparently we do have it. Cool. So next thing we're gonna do, we're gonna separate the quotient from the remainder. So we're gonna separate the last column. You can do a nice solid line, but I like to make it dash because when I make it a nice solid line, it gets me dizzy. Okay, so now. So we're going to prep this up for synthetic division. So again, you put the value of r outside the division box. The top row, you're going to put all the coefficients of the dividend, and then we begin to divide. So we look at the book and ask ourselves, how do we divide by using synthetic division? So the directions say you're going to drop down the first number as is. Okay, copy that first number as is. So we're going to put 4. And then we're gonna multiply it by whatever r is. Okay, so product of 4 and 5 is 20, and where are we gonna put that 20? In that bottom row, next column over. I love speaking to myself, so I'm gonna put a time symbol right here to remind me that I'm gonna multiply. Okay, what do we do thereafter? We're gonna add our results. You don't need a plus sign, but I told you, I just said it right now, I love speaking to myself. So let's do this. So we're gonna multiply, add. Sum of negative 22 and 20, I believe, gives us negative 2. And then what do we do thereafter? We're just going to repeat the cycle. We're going to continue to multiply, add until we're done with everything. Okay, so when we multiply, negative 2 times 5 will give us negative 10. And the procedure says multiply, add, multiply, add. When we add our results, sum of 9 and negative 10 will give us negative 1. And then we multiply and then add. Product of negative 1 and 5 will give us negative 5. And when we add the results, the sum will give us negative 5. Cool. We got another column, so we got to multiply again. Product of negative 5 and 5 will give us negative 25. And then we're going to go ahead add our results. Okay, which I think it's 3. Okay, cool. So now the question is, what is the answer? So the last row will give you the coefficients of the quotient. Okay, so the coefficient. So my dilemma is, what will be the degree? Is it going to be 4x to the 4th, 4 times x to the 4th, or something else? Now the degree of the quotient, when we're doing synthetic division, will always be 1 less than the degree of the dividend. Okay, so 1 less will be 3. So this will be x to the 3rd. And then we just go down to 0. So x to the 3rd, x to the 2nd, x to the 1st, constant. You know, degree 0. What about this guy? We don't have an x to the negative 1, but this is actually the remainder. Okay, so if we have a number in there, that will be the remainder. The question is, why is the degree of the quotient 1 less than the degree of the dividend? It's actually because it comes from math. Okay, so like if we were to do the long division, this first term goes into this first term, x goes into 4x to the 4th, 4x cubed times. Okay, so that's what we have. Okay, so now let's go ahead write the answer. Okay, so again, these are the coefficients. So our answer should read 4x cubed minus 2x squared minus 1x minus 5. Why don't we put minus 5 times x to the 0? Because x to the 0 is just 1. And then 1 times negative 5 is just negative 5. So again, I put the degrees here to make it easier for me to spit out the answer. And this will be the remainder, which we will write in a fraction form. Remember, if we got a remainder, then we have to write our answer in the form quotient plus remainder over divisor. So let's go ahead, get our answer, get our full credit. So we have 4x cubed minus 2x squared minus 1x, or we can just put minus x, minus 5, and we have a remainder, so we'll write it in fraction form. The remainder is 3, and we divide it by x minus 5. So as a fraction, the remainder is 3 over x minus 5. And that's pretty much the gist. Okay, so no matter how many terms are in your dividend, you're never gonna need more than this space. Okay, the worst thing that can happen is that it'll be like a little bit wider because you have more terms, but that's all the space that you need. Cool. So we're gonna go ahead do 2 more problems. Okay, but I'm not gonna give you the division box. I just wanted to lay out the problem. Okay, so we have our first fun problem, or fun problem number 2. We are asked to divide. It doesn't specify the technique. If you favor long division, go for it, but I do want to give you an alternative. So I'm gonna ask myself, can I take a shortcut? Can I use synthetic division? So I'm like, I don't know. Am I really dividing by x minus a number? Okay, so again, our book uses r. Okay, am I dividing by x minus a number? And the answer is yes. Okay, we are dividing by a binomial of the form x minus a number. Okay, that's it. Yeah, remind me not to use this highlighter again. Okay, so let me go ahead, write down what r equals. So in this case, the number that follows the subtraction sign is 4, so the value of r is 4. So let's go ahead and prep this up for synthetic division. So we're going to do our division box, which is just the upside down into symbol. Outside the division box, we're going to put the value of r. Value of r is 4. In the top row, we're going to put the coefficients. If you feel comfortable to put the coefficients, go for it. I don't, so I'm going to highlight the degrees. Okay, so the biggest exponent on any of the variable terms is 4. So we should have an x to the 4th, 3rd, 2nd, 1st, constant. Yeah, sorry about that. Remind me not to do that again. So we have x to the fourth, x to the third, x to the second, x to the first, constant. Okay, so it looks like I need to extend my division box a little bit longer. And then let's go ahead separate the quotient from the remainder. Okay, just like we did before. So top row, we're going to put the coefficients in the dividend or whatever we're dividing into. The degree 4 term, the coefficient is 3. The degree 3 term, coefficient is -11. For the squared term, we don't have a degree 2 term, so 0 placeholder. The reason why I like to highlight the degrees is not because I have trouble putting it in descending order, but when I'm tired, it's very easy to overlook that we have a missing power of the variable, and if we don't put it here, then that's it. We're not gonna get it right. Sorry, coefficient of the x to the first, -18. X to the 0, that's our constant term, 8. Cool. So we prepped it up for synthetic division. That will earn us some partial credit, but I would prefer if you got full credit. So let's go ahead begin to divide. So we look at the procedure. Procedure says drop down the first number. You're going to multiply and then add all the way until you can't no more. So let me remind myself that we're going to multiply the bottom times 4. Product of 3 and 4 will give us 12. And then we're going to go ahead add our results. Okay, sum of -11 and 12 is 1. And then multiply add until you can't no more. Product of 1 and 4 is 4. We keep our cool and the sum will give us 4. Let me put this down. Alright, keep multiplying and adding. Product of 4 and 4 is 16. We keep our cool, add our results. Sum of -18 and 16 will give us -2. Multiply add until we can't no more. Product of -2 and 4 is -8. And for the last time, we add our results. Okay, 0, sorry. So remember, numbers to the left of our partition will give us the coefficients of the quotient. Numbers to the right will give you the remainder, if any. So we divided into a degree 4 polynomial. So the degree of our quotient is always 1 under because the math says so. Okay, so that will give us 3, x to the third, x to the second, x to the first, constant, and then our remainder. Okay, so remember the degree of a constant term is x to the 0, so our answer should be 3x cubed plus 1x squared plus 4x minus 2, and there's no remainder. If there's no remainder, please don't highlight it. Please do not write plus 0 over x minus 4. Let's go ahead and get our credit. So let me go ahead and put answer. So we have 3x cubed plus 1x squared, or just x squared, plus 4x minus 2, and there's no remainder. Fantastic. Okay, so we're going to do one more problem and then we'll check it, because it would be nice if you check your answers. Okay, let me go ahead and write it. Okay, so let's just call this problem A, and then we'll call this one problem B. Okay, problem B, we have x cubed, so open parenthesis, x cubed plus 2x squared minus 3x minus 4, close parenthesis, and we're going to divide it by this binomial, which is x plus 2. Okay, so again, the directions do not specify what technique to use, so if you want to use long division, be my guest. But I want to know, can I take a shortcut? Can I use synthetic division? I really don't know, so I need to know, am I really dividing by a binomial of the form x minus a number? And as it stands, we are not, so that makes me sad. But if you squint really hard, we are. Okay, so we're gonna go ahead, force a subtraction. We're gonna write x plus 2 as a subtraction problem. X, we're gonna switch out the operation to minus, and if we switch out the operation, we gotta switch out the sign on that 2 to -2. Okay, you can always rewrite as long as you don't change the meaning. Subtracting -2 is the same as adding 2. So now, are we subtracting by a binomial of the form x minus a number? And the answer is now yes. Okay, so in this case, The number that follows the subtraction sign is -2, so the value of r is -2. Okay, so let's go ahead prep this up for synthetic division. So we'll do our division box. Okay, some books phrase it a little bit differently, and it doesn't really matter. The work is the same, just the layout a little bit differently. Outside the division box, we're going to put the value of r, which is -2. In the top row, you're going to put the coefficients of your dividend. So the degree is 3, so we should have an x to the third, second, first constant. Okay, so let me go ahead and highlight the degrees. So we have x to the third, x to the second, x to the first, constant. Let's go ahead and separate the quotient from the remainder. I know we have yet to divide, but it's always nice to just prep that up. Let's go ahead and put the coefficients of all those variable terms. Okay, coefficient of the degree 3 term is 1. For the x squared, it's 2. For the x term is -3, and the constant term is -4. How about that? 1, 2, 3, 4 with some negatives in there. Alright, so let's go ahead and begin the division process. So for synthetic division, keeping our cool, we're going to drop the first number and then multiply, add until we can't no more. So gentle reminder, let me put my time sign, and I need my fingers. So 1 times -2 will give us -2, and then we're going to go ahead and add our results. Sum of 2 and -2 will give us 0, and then we're going to multiply, add until we can't no more. Product of 0 and -2 is 0. We keep our cool, and that sum will give us -3, I believe. Okay, for the final multiplication, product of -3 and -2 is 6. And then that sum will give us 2. So we did it. Okay, the answer is there. We just got to get it out. Okay, we divided into a degree 3 polynomial. So the degree of our quotient should be 1 under. So it should be 2. So we should have x to the second, x to the first, constant, followed by the remainder, if any. So we have x to the second, x to the first, constant, and then our remainder. Okay, so let's go ahead and write it. So this will give us 1x squared plus 0x. We don't have time for that. We're just going to ignore it. Okay, 1x squared minus 3, and then we'll add the remainder. Okay, so our answer is 1x squared, or just x squared, plus 0x. That's just going to look weird. 0x is just 0, so ignore it. Minus 3. And then we have a remainder, unlike the earlier problem. So plus the remainder in fraction form. The remainder is 2, and we divide it by x plus 2. So as a fraction, the remainder is expressed as 2 over x plus 2. Cool. Alright, so let's check our answers, because if you have a take-home assessment, I'm pretty sure you're not going to get partial credit. So to check it, we check it the same way we do with our whole numbers. Quotient times divisor plus remainder should equal dividend. So let me go ahead and write that out. Quotient times divisor plus remainder should give you dividend. And let's say that again in English. Quotient is the number of times that it goes in cleanly. Okay, so that's x squared minus 3. Multiplied by your divisor, that's code for what did you divide by. In this case, we divided by x plus 2. And then we're going to add to it the remainder. Before we write it as a fraction. The remainder is 2. And we need to make sure, does that really give us the dividend? Okay, so let's go ahead, FOIL it out, and then add 2. Product of the first terms will give us x cubed. Product of the outer terms will give us 2x squared. Product of the inner terms will give us -3x. Product of the last terms is -6. And let's go ahead and bring down the remainder. Keep your cool, combine what you can. We have 1 degree 3 term. We have 1 squared term. We have 1 x term. And the sum of the constants will give us -4. So hopefully I didn't make a mistake, because I'm not trying to do this video again. Okay, so did we get back the dividend? Okay, did we get back what we divided into? X cubed plus 2x squared minus 3x minus 4. Oh, I'm crying. Tears of happiness. We totally nailed it. Alright, thanks guys.